Hello, we are ready for another exciting evening of math fun, and we are on the 3.2 getting ready for the problem. And this whole section is about these inverses that we have been doing. So an inverse variation is written as y equals k. Now k is a constant number divided by x. So down here, there's not a table or a graph, but I'm going to give you a table, and this is kind of like what we did yesterday at the end of the video. If 1 gives you 70, and 2 gives you 35, and 3 gives you 23 and a third, and 4 gives you 17 and a half, and 5 gives you 14, and 6 gives you 11 and 2/3, how can we analyze that data? You could make a graph of it. You could say, is this linear? Decreases by 2 and a third. This decreases by 3 and a half. Over here, this decreases by 35. So these are definitely nowhere near consistent. So I'm going to erase that right now. So this is not linear. So the next thing you're going to test is do the numbers multiply to give you the same thing. So 1 times 70 is equal to 70. 2 times 35 is equal to 70. 3 times 23 and a third is equal to 70. 4 times 17 and a half is equal to 70. Well, guess what? They're all equal to 70. So we can write our equation that says x times y is equal to 70. And you can solve that for y by writing y is equal to 70 over x. So this 70 is the constant of variation. That's the number, the k, that every single time the x times the y multiply to give you. So we're going to do the next problem. We're not going to answer these. If you were to make a graph of this, if you just recall quickly, these are these asymptotes, and the graph is not going to cross these lines because there's no shift. There's nothing added or subtracted. If there was, these asymptotes would shift. So this hyperbola is going to look like that, where 1 is going to give you 70, and it's going to get closer and closer to the x-axis, never touching it, because for the rest of your life you can divide 70 by a number and get an answer. So we have this exciting story about Mr. Cordova, lives in Detroit, he travels to Baltimore, the trip is 500 miles. And these are his different notes of his 5 different journeys. Calculate the average speed for each trip. So, rate times time equals distance. Hopefully you remember this from science. So we want to calculate the average speed. We want to calculate this rate. So the rate would be the distance, which is 500, divided by the time. Always a 500-mile trip. So rate is 500 divided by time. So 500 divided by 1.5, I'm going to grab a calculator, is 333 and a third. And then that is rate, so that's miles per hour. 500 divided by 10 is 50 miles per hour. 500 divided by 14 is 35.714 miles per hour. 500 divided by 4 is 125 miles per hour. And 500 divided by 18 is 27.7 repeating miles per hour. So I'm going to put these numbers in numerical order. So I'm going to put 1.5 first, and then I'm going to put 4, and then 10, and then 14, and then 18. I think it's just easier to look at patterns when your x is in order. And since we're doing a constant multiple, the x is not necessarily going to go up by the same amounts. So just make sure you're watching that also. So this is 333 and a third. I'm just taking this data and I'm just writing it down here. 10 gave us 50, 4 gave us 125, 14 gave us 35.7, and 18 gave 27.7. So now we're going to draw a line. We know that x times y is 500, so we know this is y is 500 over x. So we know it's going to be this hyperbolic curve. Let's make a title, Mr. C's trip to Baltimore. And I don't know if they have labels. Nope. So the x value, if you look right up here, is time in hours, and the y value is average speed in miles per hour. So this is time, this is speed, miles per hour, hours. So 18 gives 27. So 18 gives 27.7. 14 gave 35. 10 gave 50. 4 gave 125. And 1.5 gave 333, which is totally off this graph. So it's like way up here. So this is going to come swooping down, oh boy, and it should flatten right out. And it really should hit all these points. So this graph, it needs to be more flat. Okay, this is just going to be, it's going to be more like that. I'll just, so look at the blue line. It's going to be pretty darn steep because it's got to get like double height to get to 333. But these curves, these hyperbolic curves, they can hit every single point, especially when you're making this from an equation. So again, speed, let's use our words, is 500 miles divided by time, or hours. So now the question is 6, 8, 12, and 16. So 500 divided by 6, 83 and a third, 500 divided by 8, 62.5, 500 divided by 12, 41 and 2/3, 500 divided by 16, 31.25. So again, as you are getting a bigger time, your speed is decreasing. That's the inverse. These will go right over the top of our points. Like let's look at 12, 41 and 2/3. Nothing should change here. So 12, 41 and 2/3 is right here. This should go right through here in my awesome perfect curve. So nothing is changing. Every single one of those points will fit this curve perfectly. So yes, it fits perfectly. You could put them all on there right now if you'd like. Okay, so now you're given a table, and since we're doing this whole distance thing, it's probably the same exact pattern. So let's see if x times y gives a constant number. In fact, you might want to try this on your own, pause, and then play and see how you did. So 30 times 10 is 300. 40 times 7.5 is 300. 50 times 6 is 300. 60 times 5 is 300. 7 times 4.3 is 300. So how far is it from Detroit to Mackinac? It is 300 miles. So that's your K, that's your constant of variation. That's what every number is going to always multiply to give you. And so the equation would be speed is equal to 300 divided by time. So as the speed increases, the time it takes to get there decreases. So in a graph, that's going to look like this. So as x goes up, y goes down. This is a bigger x and a smaller y. In an equation, the bigger the number you divide by, the smaller your answer. So that's how we know it's an inverse, the opposite thing's happening. So again, our equation is 300 divided by time. This is the same exact equation because we'd have speed times time is 300. So we could also write this as time is 300 divided by speed. Same thing. This is the same as this. They're all the same. So if you know that you have a 45 mile per hour perfect, always 45 mile per hour, which would be really hard, you could do 300 divided by 45, and you would get 6 2/3 hours. And if you knew you could drive 65 miles per hour the whole time and never change that, it's an average speed, it would be 4.615, and there's a bunch more numbers. All right, so now he's going to drive an average of 50 miles per hour, and we're going to make a table with time and distance traveled. So after 1 hour, he will have gone 50 miles because it's 50 miles per hour. 2 hours is 100. 3 is 150. Each time we are adding 50 more miles. That's a 200. So this is not a hyperbola. These numbers don't multiply to give you the same thing. You are constantly adding 50. So this is a line. We're back to y equals mx plus b. 50 is your m, that's your slope. B is when x gives you 0, what does y give you? So your equation is y equals 50x plus 0. So to graph that, again, you want labels and a title. Zero gives 0, 1 gives 50, 2 gives 100, 3 gives 150, 4 gives 200, 5 gives 250, 6 gives 300, and would it make sense to connect the dots, do the middle times work? Yes. So we're going to connect our straight line. It should go through all the points. That's a perfect linear equation with a slope and a y-intercept. So we have our equation. And instead of x's and y's, let's write these with words. Whoops. So distance equals 50 times hours. Plus 0. You don't need the plus 0. So as time increases, more distance is traveled. In fact, more specifically, every hour, 50 more miles are driven. All right, we are going to do question 4 tomorrow. They're totally different because one is a line and the other is that thing called a hyperbola, because you're dividing by x. This is direct variation. As x goes up, y goes up. And this is inverse. As x goes up, y goes down. But I said we'd do it tomorrow, and I'm not true to my word, so I'm stopping. Have a lovely evening. I will see you tomorrow.